Thank you for reminding. We call it displacement. Are we together, members? Are we together? Members, are we together?
Yes, teacher.
And this is how it will appear, whether it is in a pool of water or is in a glass block. It will still appear the same. It will appear what? The same. So we are saying the distance from here, from the bottom up to the top of the glass block, that is what we call the real depth. We call it the real what? Depth. Then the objects, when you are looking from above here, the objects appear to be nearer to the surface of the glass block. Or to the upper face of the glass block. So it will appear, that's why I'm using a dotted line. It's an illusion, it's not true, but the real object is down. But when you're looking at it, you see it as if it's raised up. It's being displaced. It's being displaced. That's this thing, we call it displacement. So where it is up to where, to the top, is what we call the apparent depth. Is what we call the apparent what? The apparent depth. So now from there, let's have definition now. Definition. So what is apparent? What is real depth? What is real depth? So we're saying real depth. Real depth is the depth. Is the depth or is the distance? Is the distance? Is the distance where? Is the distance where the object? Is the object where the object is actually placed or lying under the transparent medium of different optical density, of different optical densities to the surrounding medium. So what is the surrounding medium here? The surrounding medium is what? Air, not so? The surrounding medium is what? Is air. Full stop. So that's the definition. So when they ask what is the real depth is the distance where the object is actually placed, full stop, under the transparent medium of different optical densities to the surrounding medium. So this is the actual distance, Then the apparent depth, is the depth or distance, where the object appears to be when observed through the transparent medium, of different optical densities, to the surrounding medium, full stop. Full stop. Members, are we together? Are we together, members?
Yes.
Okay. Full stop. Not the real and apparent depth, the real and apparent depth of an object observed through a transparent medium, or material, transparent medium, can be.
Sir, could you move your hand?
Okay. Can be used to determine the refractive index. Can be used to determine the refractive index. The refractive index of the transparent medium. So we're saying the real and apparent depth of an object observed through a transparent medium can be used to determine the refractive index of the transparent material. Okay? Full stop?
Sir, I was still writing.
Hey, sorry.
Yeah.
But it's on the screen. Are you not seeing the side of the notes? I'm just repeating the same thing on the side of the notes. Okay? It's the same thing on the side of the notes. Are you seeing the screen where there's notes? Are you seeing where the writing is?
Yes.
Yeah, it's the same, but only that the only difference, I'm trying to organize it for you so that you can have the clear distinction. I'm just trying to differentiate them, okay? Okay? Yes.
Okay.
Then from there, we can also define the refractive index, definition of refractive index. Now, definition, refractive index can also be defined as the ratio of real depth to apparent depth of a transparent material. So members, how many definitions now do we have for refractive index now? How many definitions do we have? How many definitions? We have now 3 definitions. We have now 3 what? Definitions. One in terms of the angle. The second one is in terms of speed. Then another one is in terms of depth, in terms of the distance, okay? So now we can say, therefore, refractive index N is equals to, we said is a ratio of real depth to apparent depth. So is it real depth over what? Over apparent depth. As simple as that.
Excuse me, teacher.
Yes?
Can they, like, if they tell you to define refractive index, like, will they specify, like, define refractive index, like, according to distance, or you just give the definition, which is
You just give the definition. You can define them in terms of this, or you can define them in terms of angles, or you can define them in terms of speed. They will all be considered, okay? Okay?
Okay.
Yes.
Yes, teacher.
One of the 3. One of the what? One of the 3.
Of the 3.
Yes. Are we together, members?
Yes.
Good. Any question? Any question, members? My dear student, any question?
No.
Okay. So if there is no question, if there is no question, let's let's do some calculation. Let's do some what? Calculation.
Calculations.
Now calculations. Number one. They've said, a glass block, a glass block appears to be 6 centimeter thick, 6 centimeter what? Thick when viewed from above. When viewed from above. Full stop. If the refractive index of glass is 1.52, comma, what is the actual thickness? What is the actual what? Thickness of the block. Of the what? Of the block. A glass block appears to be 6 centimeter thick when viewed from above, full stop. If the refractive index of glass is 1.52, comma, what is the actual thickness of the what? Of the block. So members, what do you think they're asking for here? What are they asking for? Members, what are they asking for? They're asking for the actual what? I mean, for the real what? For the real depth, not so. They're asking for the what? For the real what? Real depth. So from here, when you see that, let me have a sketch for you so that you can see that. We can also have a sketch of that so that you can see it well. I want you to see that. So if this is my glass block, this is my glass block, and maybe there's an object down here. If there's an object here down here, or this one here, I want you to see clearly what they are talking about. You find that light from here will move like this. Then this one also will move like that. But due to refraction, it will be refracted to some point. Here. So it will be refracted like that. Then this one will come here. So the object will appear to be that one. So even here, from here, it will be refracted like this. Then it will appear to be like this. So this way you see as if the object is there. You see as if the object is what? There. Like that, like that, like that, like that. So they are saying now the object appears to be what? 6 centimeter. What is that, members? What is that? So it's this one here they are talking about. Is this distance here from here up to what? Because they're saying was viewed from above. Was viewed from what? From what? Above. So this distance is what? What is this distance here? Is 6 what? 6 centimeters. I think that. Members, are we seeing that?
Yes, teacher.
Are we seeing that, members? Now they want us to find the actual distance, the actual thickness of the glass block, which is this one here, which is here. They want us to find these. Which is real what? This is real?
Real depth.
Real depth. But they have given us the refractive index of the glass is 1 point what? Is 1.5?
1.52.
So now what are we going to do? They want us to find this one here. What are we going to do? So we are going to set from refractive index equals to what? Real what? Real depth over what? Over apparent depth. So what are we looking for? We are looking, this is same as over 1, not so. So when you cross multiply, you find that real what? Real depth is equals to n
Depth is equals to
n time apparent
times apparent depth.
times apparent depth. I think that. So which means real depth, real what? Depth is equals to refractive index 1.5 to time apparent depth, which is what?
1.52.
Apparent depth, which is what? 6. The answer we get here
6
must be in what?
centimeters.
Must be in centimeters. So can you get for me that answer? Can you work out for me that? 1.52 times 6. What do you get?
9.1.
Is 9.1
1.8.
2
centimeters.
centimeters.
Okay?
Yes.
Are we together, members? Are we together?
Yes, teacher.
What if they were asking for the displacement? What would be our displacement? Displacement is from here up to where the object is, not so? This is what we call displacement. This one here. This one is what? That one is what we call what? Displacement. So what will be our displacement? Displacement will be real depth minus apparent depth. Okay? So let's say displacement is what? Displacement is equals to real depth minus
apparent depth.
Apparent depth. Not so? So
Yes, teacher.
our displacement will be equals to what is our real depth? Our real depth we have got is 9.12 minus the apparent depth, which was what? 6 centimeters. So what do you get? Members, what is our displacement?
3.12.
3.12. So which means the object was displaced by 3.12 centimeters. This one here, from here up to here. That distance is what? 3.12. Are we together? Members, are we together?
Yes.
Teacher.
Question number 2. Example number 2. Example number 2. They're saying a swimming pool. Members, we have only 10 minutes remaining. Let's be faster. A swimming pool appears to be 1.5 meters deep. 1.5 meters deep. Full stop. If the refractive index of water is, what is the refractive index of members? Is 1.33, not so? Refractive index of water is 1.33, comma, calculate the real depth. Calculate the real depth of the pool. Calculate the real depth of the pool and the displacement and the apparent displacement. Full stop. Solution. What?
Solution.
Members, let me just have a sketch of that. But you cannot even sketch it. You can just go straight to the calculation. You can go straight to the what? To the calculation. So what have they given us? What is this 1.5 meters? What is that? Is it the actual, is it the apparent depth or the real depth?
Apparent.
Because of the what? Appears. Okay? which means is apparent depth. Apparent what?
Apparent depth.
So apparent depth was given to be 1.5 meters. 1.5 meters. They have given us the refractive index of water, which is 1.3. Now they want us to find the what? The real what? Real depth. Then we said from what? From refractive index equals to real depth over apparent what? Over apparent depth.
Apparent depth.
Which implies that real depth is equals to refractive index times apparent depth. So our refractive index is 1.33 time apparent depth, which was given to be 1.5 meters. So what do you get? Members, what do you get? What have you got? Is
1.995.
99 what? 99 what? 5. Have we seen that, members? Have we seen that?
Yes.
Have we answered all the questions?
No.
They also want us to find displacement. Not so? We say displacement is equals to real depth minus apparent depth. So can you substitute and get for me the answer? So 1.995 minus 1.5 meters. What do you get? What do you get?
0.495.
0.495 what? Meters. Are we together, members? Are we together?
Yes, teacher.
Yes, teacher.
I think I'm very loud and clear on this.
Yes.
Okay. Exercise. Now look at the lazy one. They are yawning after me mentioning exercise. Who is that one yawning? Let's be faster, members. We have only 5 minutes remaining. So they're saying a glass block. A glass what? A glass block. 6 centimeter long. A glass block 6 centimeter long seems to be 4 centimeter. Seems to be 4 centimeter. Full stop. What is the refractive index? What is the refractive index? What is the refractive index? What is the refractive index of the material? Of the what? Of the material of the glass block. Of the what? The glass block. Okay? That is number 1. Number 2, a glass block of thickness, 4.5 centimeter is placed over a printed letter. A printed letter A, full stop, by how much? Thus the letter A viewed from above. appear to be. Appear to be. To be raised. Appear to be raised. If the refractive index, if the refractive index of glass, if the refractive index of glass is 1.5, the refractive index of glass is 1.5. Those two are enough. Those two are what? Are enough.
Enough.
Okay?
Yes.
Members,
Yes, teacher.
don't submit the work because I'm stupid to give the answer, the question, okay? Don't submit, okay?
Yes, teacher.
Don't submit because I'm stupid when I'm giving question. Okay?
Yes.
Don't submit. Yes? Yes?
Yes.
Don't submit it.
Submit.
Margaret, your network is not good. Yes, members? Members?
Number.
What? What? Yes, Olivia.
Yes, teacher.
Alexandra?
Yes, teacher.
What are you saying, Alexandra?
I said nothing, but they're asking for your WhatsApp number.
Who is that one? Up to now. Up to now. Huh. It's okay. It's okay. You have asked. The good thing you have asked for it. So should you people fail to submit the work, you will see. Use it for sending work. Don't send something else, please. Use it for sending what? Work. Members, bye. Bye, 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 bye.
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 See you when I cannot avoid it.
Likewise.
See you when I cannot avoid it.
Come to me.